Hello friends, welcome to the ninth part of our lecture, Becoming a LEED Green Associate. Preparing you for the LEED Green Associate examinations. In this segment, we're going to be looking at materials and resources. I look forward to sharing these notes with you. Let's go. So for our content highlights, we'll be looking at the conservation of building materials, selection of environmentally friendly materials, and effective waste management. Okay, so for introduction, we'll be talking about the importance of sustainable building materials and waste management. For every structure that you see around you, the foundation is in building materials. In fact, there's no construction without materials. But this has had negative effect on the life cycle of those materials right from the time they are extracted to their disposal. That is why selecting eco-friendly and sustainable materials is very important for reducing environmental impact and for facilitating the health of the occupants. So a life cycle approach is vital for improving performance and resource efficiency. So that's where waste management comes in, and ensuring that there's a preservation of the environment and that less demand is placed on raw materials, right? And the Environmental Protection Agency, EPA, has these 4 preferred strategies that are recommended. One is to reduce waste. As much as possible, we want to reduce the source of waste. Where that is not absolutely possible, then we consider a reuse of the things that would have gone to the landfills. If that cannot be achieved, then we send those materials for recycling. And finally is the waste to energy, which is the last option. So if all of these things are put together in terms of the execution of the strategies, waste can be substantially limited and diverted from landfills. Alright, so the triple bottom line benefits, of course, to reduce the amount of raw material extraction, to reduce carbon and greenhouse gas emissions that are associated with the manufacturing and transportation of these materials. Alright, it's essentially saying that we want this material volume that goes into construction to be minimized, and then we can consider the selection of certified sustainable materials that were extracted in eco-friendly manner. As we make progress, we look at details of how we describe eco-friendly manner. Economically, it minimizes the cost associated with extracting, with processing, transportation, and manufacturing of raw materials, and the benefits that are accruable from waste management practices. So the economic benefits are also profound. Socially, all building occupants are well educated about environmental sustainable practices and product selection, and this is also promoting awareness of waste management practices during the operations period of those projects. and this contributes heavily to sustainability and environment. So the idea is that we want conservation strategies for building materials and products to be implemented, right? Environmental friendly materials to be prioritized for selection. Okay? And then where waste is generated at all, there should be an effective strategy to manage the waste. So when we talk about the conservation of building materials, this talks about creating environmentally friendly design, or should I say environmentally conscious design. And there are ways that this can be achieved to minimize the need for, raw materials. During the design phase, we could consider factors such as avoiding the over-construction of roads, unnecessary use of special materials, and large spaces with no functional requirements. During the design, that should be, put into consideration. During construction, there can be a reuse of some materials, we call them salvage materials, which will also significantly reduce the demand for raw materials. All right. Also, conserving existing buildings is a good option, such that in renovating or remodeling them, only portions that are defective beyond repair can be substituted with new materials. So this automatically reduces the weight of demand on materials, on the trees and the forest, on the rocks that need to be, exploded to get materials, and so on and so forth. Okay, so we talk about design for adaptability and flexibility. And these have so many benefits: reduce waste and environmental impact, easier future renovation because you are possibly designed in modules, you've done modular setup that can easily be tweaked to achieve new spatial distribution. So using demountable partitions, movable caseworks, also reduce generation of waste and the need for raw materials. So at the design stage, architects and other professionals think modular, think flexibility, think materials that can be easily tweaked to achieving new brief or new ideas for your client. Now, oversizing corridors, exit doors, and egress stairs can support future expansion without demolition. And it gives you opportunity to take advantage of some factors that have been provided in the spatial provision to achieve new realities without needing to bring down walls and so on. And like I said before, soft spaces that also provide flexibility for repurposing areas. Don't allow your designs to be rigid in terms of the fact that they can only function for some specific activity. Those spaces with minimal introductions should be able to be repurposed for other uses, and that is important for designers to note. All right. Secondly, beyond designing for conserving building materials, designing for adaptability and flexibility, we talk about selecting environmental materials or sustainable materials. Like we said, the production, the extraction, the transportation, and the construction of building materials can have heavy impacts on the environment, both locally and globally. To minimize this impact, it's important to focus on sustainable building materials that are abundant. They are renewable. They are non-toxic. They are low in embodied energy and have no negative health effects. To identify such materials, there's an effective life cycle assessment tool that measures the overall impact of a product, the process, or the service from production to disposal. And the life cycle costing is another useful approach. This one calculates the total cost of all of this process over the entire lifespan of that product or that material. So this is essentially a strategy to promote the identification and the maximization of sustainable materials for building construction. But how do you do this? 1. Research. This is the step that involves collecting all the technical specification and relevant information concerning a particular product or material before you specify it. There are test data reports. There are warranty documentation. There are documentation that speaks to the sources of those raw materials. There are recycled material content information, issues of durability, the environmental certifications that they have or they don't have, and also compliance with local environmental codes and regulations. Now, these are the steps that are contained under research. Now, don't forget, the idea is we are trying to ensure that sustainable materials or environmentally friendly materials are engaged for our projects. And then we are saying you must identify them first. And in identifying them, there are things to look out for, and those are some of the things I mentioned here. Secondly, upon research, there's the need to assess the data that has been harvested to ensure that there's accuracy and there's no mix-up, and of course there's the necessary adherence to regulations. This may involve comparing different materials and products, with some of the tools that we already mentioned to ensure that the results are as accurate as possible. So that's what evaluation is all about. And then selection. Research has been done, evaluation concluded, and then we can make inference from the result of the assessment. The environmental attributes of the materials, and then we can make a final selection, to be able to give us some measure of actualization of the project specific objective and goals. Now you can make informed decisions about your project, and if that material suits the description of the goal of that project. Now, the cradle to cradle certified approach is a design approach that takes various factors into consideration, including the use of safe materials, clean water, social fairness, and renewable energy. This approach also emphasizes continuous reclamation and reuse of materials to ensure waste-free production without any environmental. So this is concerned about the cradle-to-cradle experience with potentially engaged materials. You are thinking holistically about the impact of that material on your this covers materials, it covers sub-assemblies, it covers finished products, described as products, for certification purposes. It's important to know that the C2C certification does not measure performance. It actually focuses on quality standards. And there are 5 levels to this certification: basic, bronze, silver, gold, and platinum. The final certification level is determined by the minimum level achieved in any of the 5 categories. So these are frameworks to guide the grading of the various assemblies and products, such that you can go ahead in your specification to say, this is the certification level we expect for the materials we intend to use for this and this and this and that part of our project. So the idea of the certification approaches is to help designers and building professionals to be able to specify in details the sustainability performance requirement, or the environmental performance requirement of the products or the materials that would be allowed to feature in their project. Secondly, we have the environmental product declaration. This is a comprehensive document that talks about the environmental impact of a product throughout its life cycle. Information on raw material extraction, how much energy it consumes, the chemical composition of that product, the waste output, and so on. And this information is expected to be transparent, and the idea is that it helps to promote the adoption of sustainable beauty materials, while encouraging manufacturers to verify the environmentally the environmental performance. So this is also a good framework that drives compliance with respect for the environment. And the data utilized for the EPDs usually collected from the life cycle assessment, like we said earlier on, and the relevant standards are usually adhered to in the process. The environmental products declaration process involves, product category rule. You must first know the rule that applies to, your product and projects. All right. This is important because the baseline information on your project is what will determine the subsequent approaches to be engaged with in meeting your project goal. So these are the processes already here, and then is there for our consumption. But then there is the corporate sustainability report, which is called CSR. There are a number of frameworks that are recognized by LEED. I'll still speak to that, but let me talk a little bit more about the CSR. The evaluations of an organization's environmental impact or social and environmental impact. Third-party verification is a crucial aspect of that process, which involves the details of the environmental footprint of a particular organization's operations, the activities around the manufacturing of their products, and of course their supply chain. Through transparency, the organization is able to establish a process that fosters continuity in its sustainable practices. But these are the frameworks that are recognized by LEED as acceptable for their standards. You have the GRI, the Global Reporting Initiative Sustainability Report. A number of you may have come across that. We have the Organization for Economic Cooperation and Development Guidelines on Multinational Enterprises, that's OECD. You have the UN Global Compact, and then the International Standards Organization ISO 26000 2010 guidance on social responsibility. All right, we'll look at some of the examples of those frameworks for you to be able to relate profoundly with them. Then we have the Health Public Declaration. Using the HPD to ensure product safety and transparency. The HPD is a powerful tool that allows manufacturers to disclose the ingredients and health hazards associated with their products. By doing this, manufacturers can offer increased transparency to ensure compliance with LEED project requirements. So this is important in ensuring that you further confirm the safety and the transparency on the history of your products. And then this talks about the concept of locally sourced materials for sustainable buildings. We have talked about the process of extraction, of manufacture, and of transportation of these materials, and a lot of greenhouse gas emissions that are released through that process. So there is the new criterion that requires that materials should be sourced within a defined radius of the project site, usually 100 miles. And this approach not only helps to decrease the project carbon footprint, but it also contributes to the local economy. Okay, so that's something you must take note of. Materials should be sourced within 100 miles, within 100 miles of the project site. That's a new requirement of LEED. Another framework is the certified wood. The certified wood is a type of timber that has been issued certification by a third-party organization, confirming that it meets the standards of sustainable forest management. Sustainable forest management refers to environmentally responsible, socially beneficial, and economically viable practices. The FSC was established in 1993 as a non-profit organization that oversees the certification of forests and companies that comply with its standards. You must have seen this FSC label on a number of products that you bought. If you look around you now, you see some of your books, some of the pack of juice, pack of electronics, that are paper-based. You would have noticed on some semi-wood materials, you would have noticed the FSC certification tag on it. I'm going to show you one on the next slide. Okay, so you can see the first picture. It's a pack of juice. That's the FSC tag just there, saying by choosing this FSC certified packaging, you are doing your part to protect forest. How do you feel about it? Yeah, so that's the goal. And the second picture is the FSC. You can see that 100% wood, the necessary labeling, saying that this is compliant with our standards, and this is on a furniture item. It's on a furniture item. So interesting. Again, we talk about the chain of custody. Another problem. The Forest Stewardship Council chain of custody, because certification is a distinction, bestowed on companies that meticulously trace and document the FSC certified material through every stage of the process of its manufacture, right from extraction of the wood from the forest to the final sale of the goods to consumers. All the intermediary stages, including procurement, processing, manufacturing, and distribution, is captured in that document. That is what the chain of custody certification is all about. The wood-based materials that qualify for this certification includes, of course, unlimited to rough, finish and miscellaneous carpentry, timber construction, wood decking, and so on. Of course, including wood flooring, cabinets, and also furniture. So that is the chain of custody. That's what it's all about. Recycled materials. We talked about recycled material content in our introduction. This content in your materials and your product assemblies can reduce the need for raw materials and also decrease the volume of waste that would have ended up in landfills, right? So recycling not only conserves energy, but it also reduces solid and liquid waste, and in turn saves cost. So projects that utilize materials with recycled content, they earn recognition from LEED for minimizing the ecological footprint and, of course, contributing to economic sustainability. You have more information there about how the recycled content is determined. Of course, it's based on weight, and of course, the credit achievement is calculated upon the cost of percentage compliance. Mechanical, electrical, plumbing components, specialized items like elevators, like other equipment, should not be included in those calculations. So I need to speak to these two terminologies for you to take note of them. You will most likely come across them in your examination. Post-consumer and pre-consumer materials. The post-consumer material refers to the waste generated by households or commercial, industrial, or institutional facilities which can no longer be used for its original purpose. Right? The waste have been generated by the end user. The product has gotten to them. They have used it and waste has been generated. So, and those products can no longer function as they were in the original state. So this post-consumer. On the other hand, the pre-consumer material refers to the waste diverted from the manufacturing process. However, this does not include materials that are capable of being reclaimed within the same process that produced it, such as reworking, regrinding, or scrap. These wastes were generated when the material was being manufactured. So these are the two different definitions of the terminologies that might interest you. PBT's source reduction. This talks about persistent bioaccumulative and toxic chemicals. PBT, sorry about that typo. It is PBTs. Persistent bioaccumulative and toxic chemicals are produced during the life cycle of building materials. It's crucial to prioritize materials with low PBTs to mitigate hazardous waste and reduce disposal costs. Furthermore, PBTs can pose a health risk to cleaning staff, which means that there's urgency for the drive on eco-friendly materials procurement. So that's why sustainable purchasing practices is a good way to promote the selection of environmentally friendly materials and products. Of course, there are examples that will interest us in this goal of ensuring that every material procured has given adequate thought to sustainability. Now let's talk about waste management. Like I mentioned earlier, the construction process generates a significant amount of waste that accumulates throughout the building life cycle. Most of the produced waste unfortunately get to be dumped in landfills for incineration and combustion. Only a small fraction of waste is repurposed or recycled. And so the incineration process contributes to carbon emission because the solid waste transportation contributes to greenhouse gas emission. That is why implementing waste diversion strategies is important to reducing waste production. From proper designing, like we mentioned, to source reduction, and also the implementation of systems that minimize waste production. These are all very important strategies for reducing waste. The Environmental Protection Agency, like I mentioned earlier, recognizes source reduction, reuse, recycling, and waste to energy as effective strategies or preferred strategies for managing waste. And of course, there are a number of ideas from the various phases of construction activity that have been developed to guide professionals and building users to engage in environmentally friendly waste management approach. Let's look at those strategies. The strategies will be considered during the following phases. the design and planning stage. What are the strategies that can be incorporated at the design stage? What are the strategies that can be adopted for the construction waste management? And what are the strategies that can be adopted during the building operations and maintenance? Now, for the design and planning stage, it is important that effective waste management must constitute an integral part of the design process. You must think about the impact of your design on waste generation. Prioritize modular design, flexible units, and precast structures. These choices would significantly influence the quantity of waste generated and also minimize transportation costs. It is important for the design team to identify the types of materials that will be generated based on the assumptions that have been made in the project design process, and make their recommendations, in terms of the appropriate procedures that the construction team should follow in ensuring that these projected waste are either nullified, minimized, or well managed. So this is important for the design and the planning stage, and designers, building users need to particularly take note of this. So source reduction is the most effective approach to waste management. That is to say, don't generate waste. And this is by introducing source reduction techniques right from design. This should extend to manufacturing and procurement, ensuring that precise sizing and proper selection of deliverables is done. Smaller packaging and concentrated products are generally more sustainable because they use fewer materials and less energy to produce and to transport. Right? Now, let's talk about the waste management plan. There is need for a comprehensive plan that details the diversion strategies and how waste will be recycled, salvaged, or reused. The plan should take into account the collection and sorting of materials, whether on-site or commingled, to determine the hauling company's contracts and, of course, the necessary manpower to sort the materials. In achieving success, the plan is to be distributed to all contractors and subcontractors involved in the project, and then you conduct awareness sessions to take them through the expectations as contained in the document all through the construction phase to encourage participation. Of course, the credit calculation does not involve hazardous waste, which is expected to be disposed according to relevant regulations. So, I haven't spoken to source reduction, recycling waste under the waste management plan is where emphasis is placed on recycling construction waste instead of taking them to the landfill. This is a part of LEED sustainable building practices. Recycling waste minimizes the need for raw material production. Reduces carbon dioxide emission that arises from transporting new materials. Construction projects are encouraged to collect waste materials, separate them on site, and sell any recyclable waste to recycling facilities and manufacturers. In some regions, it is possible to donate recyclable waste as well, depending on the available facilities. Now, commingled recycling. We just spoke about sorting out your waste and then inviting recycling facilities. One of the alternative approaches to recycling materials is the use of commingled container. Show you a picture of an example of that as we go on. This means that all your waste materials are collected in a single location, which is now transported to a recycling facility where segregation would be done. This is primarily useful for construction sites because it reduces the need to engage laborers for sorting on the site, which may now, minimize the area required, which also minimizes the area required for waste management. So it doesn't tamper with the site activities as it were, especially for mega constructions. This can lead to increased cost because the recycling facilities now have additional responsibilities, but whichever way the cost will be spent. So it's an approach, and it's important to differentiate between recycled content and recyclable materials and products. So recycled content refers to the materials that contain recycled items within their components. That is, recycled items were part of the materials used to make them. So it has a content of recycled material, right? So this contributes to the recycled content credits in the final product. Recyclable materials are those that have been previously used, and can be repurposed or for creation of new materials. All right, so you need to understand the difference between the two. So this is an example of a commingled container. Here you find all kinds of waste. That's what it looks like. So it gets to the recycling facility and then the sorting is done. So this takes the stress of segregation of the construction site. So we have waste to energy. Even though LEED does not view waste to energy as a conventional method to earn credit, it can still be engaged in some specific circumstances. For example, where waste materials cannot be recycled or reused, the waste to energy option can be adopted. However, to use this method, some regulations must be adhered to. The frameworks listed there, you may want to acquaint yourself of it, and it's important for you to know that the strategies have been arranged in their order of preference. This is just an option where you are not able to reduce source, you are unable to reuse or repurpose, you are unable to recycle. The waste to energy is an option. So as we begin to round up this chapter, let's now look at the operations and maintenance waste management. We just finished talking about waste management during construction. Now let's talk about waste management when the building is already being occupied and operations are running, and maintenance is also ongoing. To develop an effective waste management plan, it is crucial to conduct a waste stream audit. That refers to a systematic review of the amount and composition of waste generated, as well as the techniques used for waste disposal. The audit is expected to cover all consumables utilized in the building, except for any durable goods or debris from construction work. By conducting the audit, a baseline can then be established that talks about the different types of waste, their weights, or their volumes. And this information will now assist in identifying the opportunities for recycling, enhancement, and waste minimization. And the audit is best performed during the performance period of the building to ensure accuracy. Right? As a roundup, the waste policy is also an important documentation to handle the various types of waste produced during daily operations, including mixed paper, corrugated cardboard, and so on. It's vital to implement a comprehensive waste management system. The waste should be categorized into 3 groups: ongoing waste, durable waste, and hazardous waste. And so this policy should detail the different type of waste and how they're expected to be handled. It's also expected to extend to products that fall under the purview of building and site management to ensure maximum efficiency. Right? So that policy is some documentation you must have that tells everyone who interacts with the building, the facility managers, occupants, the designated consultants, or what have you, the building's expectation has already projected even from the design phase, which you must now supervise to ensure that there is proper execution of the expectations of the project owners. Finally, ongoing purchasing. Extracting, manufacturing, using, and disposing of products can lead to harmful environmental and human health impacts. To mitigate this effect, it is essential to implement ongoing purchasing and waste policies within building operations. An environmentally preferable purchasing policy has been put in place, which prioritizes purchasing products with green attributes and setting a framework for the implementation of that policy. This policy involves ongoing purchases and the procurement of durable goods to ensure a sustainable approach. And this document guides procurement of consumables, materials in support of the operations and maintenance of the project upon delivery and occupation. That's the chapter 9 of our lessons on becoming a lead green associate, and I'm sure you've picked one or two lessons. We will be proceeding to the other chapters as we begin to gradually round up these lessons that we've been on with for some weeks. So I wanted to thank you for staying with us. I will see you in the next class.